last topic is extended ER. Most of the students, they make a mistake of learning the ER process and stopping the ER diagram at the basic fundamentals. But rather, we need to consider these three things. Other than that, one more is nothing but inheritance, where these four topics will be the most important one when you're actually building or drawing a real-time ER diagram for a system. Generalization is nothing but a process where you're extracting common properties from a set of entities and creating a generalized entities for it. Basically, if you see, we call generalization as bottom-up approach, where in which two or more entities are combined to form a higher, two or more entities are combined to form a higher level entity. Example, when you see an example, you will understand. Here, if you see, this is a most simple way to represent generalization. Here, pigeon is an entity, sparrow is an entity, dove is an entity, where I can combine all these three through a bottom-up approach, and where I can combine it to birds. In an ER, I would represent it in this way, where vehicle, if you see, is going to be the superclass entity, where I have car, bus and motorcycle as subclass. Example, vehicle can have a common information like the registration date of the vehicle, the type of vehicle or the color of vehicle. All these things can be common for all of them. But individually, these entities can have their own attributes as well. So in generalization, we call it as bottom-up approach, where from bottom, we try to combine and form a entity class. Most of the students, when they see these diagrams, they don't know the difference between generalization and specialization. If you see the diagram for generalization and specialization, it will use a feature called is-a. Okay, it's a relationship that is used. Vehicle is a subclass of car. Bus is a subclass of vehicle. Motorcycle is a subclass of vehicle. Car is a subclass of vehicle, where vehicle is a superclass. So when I see it, I would see it as a bottom-up approach. But if you see the diagram for specialization, it would look exactly the same. But the only thing is that the way it is interpreted, when you're building in a generalization, small components put together, I can form the top approach. It is bottom up. Now we will see specialization, then you will understand the difference. Here, if you see, specialization is nothing but an entity is broken down into sub-entities based on their characters. So here, if you see, I'm going to take person, which is an entity, I'm going to break it down as student and teacher, because a person will have common attributes that can be shared by both student and teacher. Only thing that will be different between student and teacher, if you see, person can have ID, student also can have ID, faculty also can have ID. Student can have date of birth, faculty also can have date of birth. Address is also common for both of them. Then phone number, email ID, everything can be a common attribute for these two entities. But if you see, a student's pay fees, teacher draws salary, those can be the attributes for unique for these two entities. So when I want to tell it as a top-down approach, vehicle is can be broken into car, bus and motorcycle. Here, if you see, it is the opposite, where the superclass is actually divided into subclass. Technically, when you see both the diagrams, it looks the same, but the only thing is that the approach in which you draw it is going to make the difference. Diagram, if you see, looks the same. The interpretation, here I am taking all these three different entities like sparrow, pigeon and dove, I am combining it to a bird. Or I see that, oh, there are common features that are common for all these things and which I can make it as a vehicle. I am trying to do it bottom up. I first draw this, from this I infer and make the vehicle. On the other hand, in your specialization, I see that, okay, a person can be broken into student and teacher. So when I'm drawing it, the inference changes. But if you see diagrammatically, both of them are same. The next important one, if you see, is inheritance. Inheritance is nothing but the higher entities will be sharing the attributes of the lower entities. The lower entities will be allowed to share the attributes of the higher entity. Example, vehicle is an higher entity or the so-called superclass, whereas car, bus and motorcycle are the subclasses. In this one, vehicle on its own is having three different attributes: the make of the vehicle, model of the vehicle and chassis of the vehicle. So if you see, a vehicle can have these three attributes. When I'm going to see a car can also have all these three. So example, it can be a car can have a make Hyundai, which model, maybe I-20, and what is the chassis number of the car. Bus, if I see, is a vehicle that can have a make Tata Motors, the model of the bus maybe T400 and the chassis of the bus. In case of a motorcycle, the make of the motorcycle can be KTM, the model of it is Z5 and the chassis number. So in this case, if you see, when you see from the bottom up, it will be generalization. When you see from the top, it will be specialization. Now you can ask me, car, if you see on its own, is having a particular entity. Bus, if you see, is going to have a particular attribute. Bus is having its own attribute called as seat number. Motorcycle is having its own attribute number as load capacity. This, if you see, is unique to these attributes. So motorcycle's load capacity is not shared by either bus or car. They are unique on it. But on the other hand, the attributes that are there for the vehicle is shared by the lower entities. Now, we are going to see an example how this is represented. Here, if you see, a person is having name, street and city. Any person or any individual can have it. If you see, a person is an employee and also a person can be a customer in the same shop or in a bank. So here, if you see, a customer is having their own particular attribute called as credit rating. So a customer will not only have their own attribute called as credit rating, but will be inheriting the attributes like name, street and city from the person entity. Same thing is for the employee. If you see, employee is an entity that is derived from the person. So if you see, for an employee, salary is its own entity attribute, but if you see, it will also possess name, street and city. Now you can see this is level 1 of your breaking down. Now in case if I am breaking the employee again, where an employee can be either an officer, can be a teller, can be a secretary. So from an entity employee, I am breaking down into office, teller and secretary. And each of these entities are having attributes. Example, secretary is having an hours worked. On the other hand, officer is not having the hours worked, rather an officer is having only office number, which is not shared by either of them. But if you see, an officer will have a salary, secretary also will have a salary, teller will also have a salary. So that is a speciality. When I am going to write it as tables, we will see, you will understand it clearly. So the first entity I am going to take is customer. So a customer is going to inherit all the attributes of the person. So name, street, city is derived from person, and also customer is having his own attribute, which is nothing but credit rating. Now we are going to see one level below, officer. If you see, officer is going to inherit all the attributes of employee, and employee is inheriting all the attributes of a person. So an officer will have a name, street, city, and also the attribute of an employee, salary, and his own attribute, office number. Same goes for the teller. Name, street, city, salary from the employee, station number and hours worked. Now, if you know, automatically by this time you will understand what will be for the secretary, right? Name, street, city, salary and hours worked. So this is how your table is created and this is how you will have inheritance in your diagram. Now, the last topic, which is nothing but aggregation. Aggregation, if you see, is the most important topic which will give a new dimension to your ER diagram. So, if I want to, this is based on the concept of relationship. Till now, whatever we have seen, it is impacted by the entities or attributes. If you see, generalization and specialization were relevant to the entities. On the other hand, your inheritance was relevant to your attribute, whereas aggregation is relevant to your relationship. It is used when we need to express the relationship among relationship. That might be confusing. It is not relationship between attributes, entities, but between relationship. If you see, aggregation is an abstraction through which relationships are treated as a higher level entity. So when you see it as an example, you will understand. So what happens is that in this process, when two entities, okay, are having the same relationship as a single entity, again the single entity can have another relationship. We will see with an example of a ternary relationship. An employee works on a job at a particular branch. An employee works on a particular job at a particular branch. This is a ternary relationship. So in this one, if you see, we are forming an aggregation between these three. Suppose in this relationship itself, I am trying to include a new third entity, a fourth entity called as a manager. A manager is assigned to a job to monitor the employee. In that case, if you see, employee works in a particular branch on a particular job where the manager manages that particular job. So now you can ask me, why are we not connecting the line here, rather it is over here? Because not all the managers are working on all the jobs. Or also if you see, there are some jobs that are exclusive to some managers. In that case, when I want to represent this particular relationship, when I want to do this, we are trying to remove the redundancy. Rather than connecting all the entities and relationships, we are trying to connect and give a new dimension to it. That is, we treat the relation as an abstract entity. Second thing, we allow relationship between relationship, and the third one is abstraction of a new entity. So in this one, if you see, I am combining job, employee and branch based on a relationship called on works on, where this works on is connected to the managers and for manager. Now you can ask me, in the last diagram I said not every manager is part of all the branches. Yes, that's true. And not every manager is part of all the jobs. We believe or we assume it is a common space where this can be connected for each and every record rather than the entire table. Okay, this if you see is going to be part of your aggregation. With this, I end my ER diagram presentation.